is a talk given by the keynote speaker, Mr. Kiazand, Chief Executive Officer, Member of Board in iCloud Acropolis. The title of his talk is Open Source for iCloud Providers. Or you want to take it with you? I'll take it with you. Okay. Thank you very much.
Good afternoon, everyone. As mentioned, my name is Kiazand. I'm from Cloud Acropolis. We've been working in Cloud Acropolis for the past 2.5 years now. As a matter of fact, I wanted to thank Jill for his presentation because he paved the road for whatever we do. We are not an open source developer. We are an open source company. All our businesses are based on open source. That's how we built our data center. So literally now it's an example of a company who has built a business, a reliable and beneficial business, not only for our pocket, but also for Oman. So we're going to talk about who we are a little bit and talk about the story. We are an Omani company. We are listed in Oman. We are in Al Ghobra, by the way. So we have our own data centers, and we offer our services from there. So it's a local story, as a matter of fact. The company was registered in 2016. Right now, we have our data center in Al Ghobra. As I mentioned, we are connected to all operators. We are connected to at least 2 power lines. We've had our availability at 100% since October of 2017. 30th of October 2017, that's where we got our first customer. Until today, we've had 100% availability, all based on open source. Our customers are SMBs, all the way to the government, to this university, to ITA. As a matter of fact, FOSS.om is hosted on our servers. Now, very quick. We are providing, basically that's our location. We are connected to everyone. We are offering colocation, physical servers. Everything is redundant. We are offering virtual machines or cloud servers. We are offering backup as a service, managed network security as a service, and there's an understanding of how we can move to the cloud. Any application can move to the cloud. It's not that your application, you just put it on a server, it's on the cloud. The security is an issue. The way to do the architecture differs from local to the cloud, and we can help on that as well. Obviously, we offer domain registration, domain hosting, and here below we offer ERP, document management system, based on what Frank presented, Nextcloud. As a matter of fact, we are using their services for our own, but also a lot of our customers in Oman and outside of Oman are using Nextcloud. It's a great product, obviously open source. He presented very well yesterday. One thing he didn't approach is the security part. As a matter of fact, it is so secure you can put legal information and even passwords inside. There's a great password management inside. All right, so let's take a look at the history, how the application, how this IT service has been evolved from the beginning. We had silos. So we had one application, you had the middleware, the database, the operating system, the server, the storage, and the network dedicated to it. As a matter of fact, today, some of the telcos, local or even international, they're using the same thing. So, for example, if they have a billing system, the billing system has its own storage, server, database, etc., etc. So that's how we used to have IT. Quite old. Now, I think in the year 2005, 2010, we moved to some sort of a virtualization environment, and we concentrated into having a single storage, high available, of course, but a single centralized storage. So we had the processing on a virtual platform. We had the network on the side. Of course, we had VLANs and stuff. And then we have SAN, which was a centralized storage. And we would build the operating system on top of every single virtual machine. And the virtual machine had its own database, then the middleware, and then the application was on top of it. And the communication was done through network. Now, the network could have been virtual or physical. Today, it's a bit different on the cloud. Of course, we have the physical layer, servers and storage, but the storage has become a software-defined storage. It means that we are not using a single storage, a single node of storage, and replicating it. No, we have a node or multiple nodes communicating with each other. Every time that a data is written somewhere, it writes it to all its nodes. Now, all its nodes, imagine they are connected through 10 gig or 100 gigabit per second fiber. They can be in one area or they can be in multiple areas as long as the network allows you to do that. So it means that you have a disaster recovery right away, just with a software-defined storage. On top of that, we have the software-defined network and network function virtualization. Well, this is your firewall, this is your router, this is your load balancer, etc., etc. And then you have the virtual platform, of course, the virtualization at the processor and the RAM level. So you can still have your operating system on top of that, but you can have an operating system and build your database on top of it, or share that operating system in between different applications. You can have Dockers, for example, all right? Or you can have your database also shared in between different applications, and your middleware also shared in between different applications. So it means that literally, whenever we talk about cloud, we are looking at basically users can put only their application on the top, and the rest of it would be provided by the cloud provider. Why I'm talking about all these here? Because all of these, all the color ones, basically from here to the top, they all can be open source. As a matter of fact, in Cloud Acropolis, we put them all in an open source environment. All right? Now, if you take a look at OpenStack, for example, yes, they have every single component. They have the networking, they have the storage, they have the processor, they have the distribution, but, you know, it's too many flavors. Right now, you have the OpenStack of Huawei, OpenStack of HP, OpenStack of VMware. It's not open. It's literally, it's not open anymore. So for me, as with a background in Unix and open source, it wasn't appealing to me. And also, if you take a look at all the components that a business needs, which is beyond the technology, we are talking about the billing system, we are talking about the CRM, we are talking about an HR system, etc., and all integrated, by the way, to the entire ecosystem. OpenStack doesn't have all the necessary components to make sure that your business is able to run the way it is supposed to. So we have another approach. So we said, all right, rather than going a closed source, we go open source, and we try to integrate all of them. And these are the different components that we use, literally, to be able to provide cloud services. I'm going to go into every single one of them. Let's see, yes, I have time. On the server virtualization, of course, you have VMware, we have Parallels, you have Citrix. We are using KVM. It's basically a Linux-based virtualization environment. Of course, you can use Zen as well, but this is a KVM-enabled environment for, let's say, virtual machines. On the network, there's Cisco, there's Juniper, but for network function virtualization and software-defined network, we are using Cumulus. Open source, of course, we adhere to the support, so we have to pay for the support part of it. Again, it's open source, it's extremely viable, it's highly available, and it's extremely performant. We are talking about microsecond latency in our network with Cumulus. We couldn't get it with Cisco. Again, open source. Storage. You have HP, you have EMC, you have Dell, but we are using SIF, software-defined storage. This is basically you get a very simple server, physical server, you add storage into it, and you manage the hard drives in a different manner, in a software manner. And basically all the data that goes inside of your storage, it's being replicated node by node. Again, with this, we are reaching at the basically at the read-write level. We are reaching 3.2 gigabit per second with SIF. I could not reach it with NetApp. I could not reach it with EMC. 3.2 gigabit per second. That's what we have at write. What does it mean, literally? Those latency I was talking about. This is the difference between today and tomorrow, which is 5G. We are talking about driverless cars or driver-assisted cars. Imagine that a car is going forward and then it needs to change the lane. You cannot wait 19 milliseconds for your network, for your 4G, to come to the data center, make a decision, do the processing, read the data from your database, make a decision, go back to the car, and tell the car, yes, there's a car behind you, don't change the lane. It's not possible. When 5G comes in, they take that 90 milliseconds away. How about the rest of it? Processing, reading, and answering back. That needs to happen also at less than 1 millisecond. With open source technology, we have been able to achieve that performance. All right? With open source. IT service management. You have the BMC, you have Manage Engine. We are using Zabbix. Of course, you have to install Zabbix engine in everywhere and basically do an SNMP trap. That's fine. We get the right virtualization, we get the right, monitoring, we get the right information gathering, and we are able to automate a lot of things. It's possible to do that, and that's what we're doing. IoT, of course, we have the Watson and HP, but we are using Ka for a lot of IoT bases, basically doing the measurement, power measurement at the at the power meters. It's possible to do that. Ka has a lot of APIs that grab all the information with many protocols, with whatever protocols available today, and does the processing. All right? And it gives you basically the right report at the right time. AI, DeepMind Watson, TensorFlow, open source from Google. To be honest with you, we want to use it, but we haven't had the case yet. The case study that they showcase on their website, it's literally tracking the fish inside of the Pacific Ocean and see where they're going, how they feed, what the global warming effect was on the fish, specifically in the Pacific. That's what they use TensorFlow. The cloud management, basically, I'm talking about the brokerage. Odin, closed source, Proxmox, open source. Very good technology. Whenever we read on the website, they were saying it's all about test platform and lab. No, it's not about just lab. Just take a look at our data center. We are running many servers, many storage on it. It has a very robust firewall, open source firewall on it, and it has a lot of integration with the rest of the business. As I was saying, basically, whenever we provision a virtual machine in an automated way, we have to get the invoice running. The customer needs to be defined. So it has to be integrated. Everything needs to be integrated for the CSP to run. And Proxmox has all the capabilities that we need. For CRM billing, Flexient, all WHMCS. That's what we have. You go to our website, it's all WHMCS and it's all WordPress. Again, open source. We code into it, we modify it a little bit, but this is what we are using. Backup recovery, that's today we still have an issue. Of course, there's Acronis, VM, or Veritas, or we take stateful. Stateful backup it means that we take an image of the virtual machine at a given time and we host it. Well, the problem that was raised this morning is scalability. Whenever you take an image, it takes time, and it takes a lot of effort from your CPU. All right, so you get backlog on your CPUs. Whenever you have many virtual machines, then basically the CPUs of your server are getting backlogged. So it doesn't work. Basically, your operation has to stop for your backup, and that's not acceptable. So today, we are using Acronis, to be honest with you, because we haven't been able to find the right way of, or the right open source application to do the backup in an incremental way and in a secure way, let's say. Now, the challenges. I'm talking about very limited support. Why? Because we are running a business. Whenever we are talking to the open source community, there is support, but there is not support whenever you need it, which is now. Whenever we have an issue, the issue is happening now, we need to fix it now. So we cannot rely on a community to provide us support. The support might come in 1 day, in 2 weeks, in 3 weeks. So if we rely on the community only, we cannot run a business. We have to get actually the enterprise licensing or the enterprise support. In some cases we did. We weren't happy about it. In some cases we didn't, to be honest with you. So we had to develop a lot of knowledge and expertise ourselves. A lot of sleepless nights. All these need to be integrated. All the parts that I mentioned, plus many more, need to be integrated, needs to be worked together. Frank is here basically just to get Nextcloud into our I would say platform and provide it as a service, including the CRM, including the sales, the billing, the provisioning, etc., etc. That requires a lot of work, and it wasn't done. Nextcloud by itself is a good product, but whenever you want to bring it into the business and provide it as a cloud, then you need to have all these ecosystems working together. And basically, we had to work a lot. Bleeding edge. I didn't say leading edge, I said bleeding edge. Because whatever you have in the market right now today, you have the Microsoft of the world, you have the HPs and EMCs of the world. They say, well, we are doing it that way. And open source, take a look at the final product and provide the same things, if not better. So the tests that have been done on open source for scalability are not there. They're good products, no doubt about it, but the tests for scalability, for reliability, for longevity is not there. You have people at the community who do programming, and they do a very good job. But how many load tests have been done? How many penetration tests that have been done? How many X tests that have been done? So you need to actually do all those tests, and you need to do all those tests in an integrated way. For us, trying to penetrate the Linux as a service is not the final test for us. It's how, let's say, ethical hacker from outside go through the entire ecosystem, reaches the data inside of the database and try to get it back. That needs to be tested. Do we need to have an extra security level on the CRM? Is it the cloud provisioning system? Is it the virtual machine itself? It's the Ceph, the storage management system. It's the database, the MySQL or MariaDB. So the entire thing needs to be tested. And therefore, we need to literally be at the bleeding edge ourselves to be able to test all these and to provide the service at the end of the day. So basically, going into the open source business, let's say using open source for the service for a company, we need to do coding, and coding. There's, from my perspective, actually, from my experience, we have literally hired coders. And myself, by the way, from the background, I'm a Unix programmer. So we did a lot of coding to be able to integrate all these things together. Of course, the cost of license is lower. The cost of HR is higher, but the way that we did it, because we did automation, the initial cost of human resource was higher. Now the operation is quite smooth. Right now we have basically 2 or 3 high-end engineers, coders basically, who have an understanding of cloud, and they take a look at the entire system at the problem level, not at the incident level, because we get few incidents. Problems, again, if we get one, then we all shake and we try to solve it as soon as possible. So basically at conclusion, that's my last slide. Conclusion is that if you want to use open source, and I really encourage everyone to use open source, please remember that you have to have coding experience. You have to think out of the box. You have to use your network a lot, as a matter of fact. You have to create a community or be in the community, in multiple communities. And you have to think about integration. Not everything comes integrated out of the box whenever you talk about open source. And that's it. Thank you very much.